Yeah, very good morning, children. We are going to continue with our classes. And in some of the class, I have not derived the formula regarding the conservation of mass. So today I'll be deriving the formula of conservation of mass, and we are going to solve some problems based on that. Force and laws of motion. What is conservation of mass? We have already defined the conservation of mass. Correct? What is the conservation of mass? The conservation of mass, it is the sum of the momentum of two objects colliding each other before collision and after collision. What is the momentum? What is momentum? Momentum, it is the, what is momentum? It is the force applied by an object. Yes or no? Here, what we are going to derive is, you will be having two objects. Okay. Let the object mass be m1 and m2. Now, before collision, how it will be? After collision, what is the force? If you add before collision and after collision, what is the unit or what is the formula you are going to get? That is all about your conservation of mass. So let us start with the diagram first. So it is before collision. Before collision. So where is the mass of the object be? The object will be far apart from each other. Let this be mass 1 of an object and this be mass 2 of an object B. Okay, now before collision or before the vehicle starts, what will be the velocity you will be applying? It will be the initial velocity, and initial velocity is represented by the letter U. Correct. Now, let me take it as, or let me take this as MA, that is mass of the first object, and MB, the mass of the second object. And the initial velocity will be UA, and the initial velocity of B object will be UB. Now, you have come to know that you will be having the mass of an object M and MA and UA of an object A before the collision, and the object B also remains the same, that is MB and UB before the collision. Now, if the object is moving, okay, you will be having a queue, you will be moving in a queue. You will be having an equal distance between the two members and you will be moving. Sometimes what happens, the other person who is sitting at the back or who is standing at the back, he will come and rush. Correct. When he rushes, what happens? He will hit you. Yes or no? Here also, the two objects are going to collide each other at the point of collision or at collision. At collision, what happens? Both mass, that is object A, is going to collide with object B. Now, if that person comes and hit you, your mass get reduced. You will reduce your mass to 10 grams. No, your mass won't get reduced to 10 grams, or your mass you won't, whatever the mass you have, it won't be more also. Correct. It will be same only. Here also the mass of both the objects remain same. That is MA and MB. Now, what is the force of acting? Now, what will you do? You will be putting the force in the opposite direction where the person is coming. And the person will also put the force on you because it is colliding. Both people are getting collided with each other. You are fighting. So, it will be force A, which is acting on the positive direction, and force B, which is acting in the opposite direction. The force which is acting on the opposite direction. How is it represented? It is represented by a negative value. Yes or no? It will be represented by a negative value. Then now it will be collided. After collision, what happens? They get free. What? After fighting, what will you do? You say, hey, go, get out from here, and you will move, and the person who is getting fighting also, he will also move. Same thing happens here. After collision also, A object moves along with this mass. Yes. And B object also moves along with the mass. Here it met each other. Here it did not meet each other. It was initial. Now it has been met and it has been passed as time. Everything has happened. Then what happens? It is moving now. It is the final thing. It is moving. So what is the velocity you will be representing for the final? It will be final velocity, which is VA, and this will be VB. Understood? The final velocity is represented by, or the final velocity is represented by which letter? That is V. That of a mass A will be represented by VA, and velocity of object B will be represented as VB. Clear about till here? Now let us derive the formula. How to derive the formula? What all the things you are going to remember when you are going to derive the formula is, you have the Newton's second law of motion. What does the Newton's second law of motion say? The force is equal to mass into acceleration, or mass into velocity. Mass into acceleration. Newton's second law will say whatever the force you are going to apply on an object will be equal to the mass of an object and acceleration of an object. Next, in the first chapter, what did you learn about the acceleration? Acceleration is what? Difference in velocity divided by time taken? Yes or no? It is difference in velocity divided by time taken. What is the difference in velocity? That is final velocity minus initial velocity divided by time. Yes, correct? Now, let us use these two formulas and find out what is the force of A and what is the force of B. Now, using the first one, initial and final velocity. You are going to use initial and final velocity. Find out the acceleration of mass A or of object A. What happens? Acceleration AA will be equal to, how will you write? That is the final velocity minus the initial velocity. VA minus UA divided by. Correct? Yes? Now, coming back to Newton's second law. What is Newton's second law? Force of object A will be equal to mass. Mass of the object is what? MA. Correct? Into acceleration. That is A, acceleration of object A. Then FA will be equal to MA into mass. Acceleration of object A is already been derived here. So it is VA minus UA divided by 2. Did you understand this one? Clear for everybody? So this is the equation number 1. Again, similarly, acceleration of object B. What will be the acceleration of object B? AB will be equal to final velocity of object B minus initial velocity of object B. That is VB minus VA divided by T. Yes, I do not have time, different times. I do not have. Here it is the meeting time same. Both are getting collided at each other and they are getting vacated at each other only. So the time is constant for both at collision and after collision. So I am going to take the T same itself. Then what happens? FB will be equal to MB into AB. Yes or no, children? FB will be equal to MB into AB. Now what happens? FB is equal to MB as it is. In place of AB, what are you going to write? You are going to write BB minus UB divided by C. This is second equation. So your first equation and the second equation is ready for us. Now what happens? What does the Newton's third law says? What is the Newton's third law, children? Every action has equal and opposite reaction. If you beat me, I'll also beat you. Yes or no? If you scold me, I'll also scold you. If you give me some book or help me in the need, even I will be helping you in the need. The same thing here also, Newton's third law says, For every action, there will be equal and opposite reaction. If your mom calls you, what will you say? Ah, I'm coming. You say right. That is what you are also. Force of object B is equal to force of object B. Equal and opposite reaction. Object A is in positive, but object B will be in the opposite, in the sense it is negative. Understood? Now substitute what is FA, MA into BA minus UA divided by T is equal to minus of MB into VB minus UB divided by T. Correct? Yes? Now see the denominator. Both the denominators have T. Correct? So cancel the T's. Both the denominators, if it has the same value, then you are going to cancel it off. So T gets cancelled. You will be left out with MA VA minus UA is equal to minus MB VB minus UB. Now what will you do with this MA? You are going to multiply this MA inside, and even this MB also you are going to multiply it inside along with the negative sign. You are going to multiply it again along with the negative sign. So MA into VA will be MA VA minus MA into UA will be MA UA is equal to MB into VB is minus MB VB. Minus into minus will be plus. MB into UB will be MB UB. Dear children, till here. Now what are you going to do next? You are going to shift the terms. How are you going to shift? Your initial velocity, all the initial velocity one side, all the final velocity one side. So here the final velocity is already positive. So let me keep it as it is. MA, as it is. Here the final velocity is a negative. So let me take this side. What happens? It becomes positive. MB, BB is equal to here. It is already positive. Let me write as it is. MB, UB. The initial velocity of object B is already positive here. But here the object A it is negative. So let me bring it this side. If negative comes this side, it becomes positive. MA, UA. So what you have? MAVA plus MBVB is equal to MAUA plus MBUB. Clear? Now, what is the conclusion you are going to say for the conservation of mass is the sum of momentum of two objects before collision is equal to the sum of momentum of an object after collision, provided external unbalanced forces applied on them. This is what you are going to say. See, before collision, what is the velocity you are going to represent? It is the initial velocity, sum of momentum before collision. Momentum, you will be representing the second law of Newton. What is the second law of Newton? It is F is equal to MA, correct? So it is MAUA plus MBUB, and here also it is sum of momentum after collision. After collision, the velocity is represented as UB, VA and VB, correct? Then you are going to say it is VA, VB plus MB, VB is equal to MAUA plus MBUB. Clear, children? So this completes your chapter, that is force and laws of motion. The only thing you will be left out with problems. So let us start solving the problems. The first one is, I'll do some problems on the board and some will be given in the notes. Okay. So copy the problems. This class and the next class I'll be solving some problems, and then I'll start with the next chapter. How much net force is required to calculate, or how much net force is required to accelerate accelerate a 1000 kg car at 4 meter per second square. Now, what is the thing? Based on which all formulas you will be having the problem? Based on the Newton's second law of motion, and you will be having the formulas based the problem based on conservation of mass or conservation of momentum. You will be having the formulas based on conservation of momentum and conservation of and Newton's second law. What is the conservation of momentum? Says you it is the sum of the momentum of an object before collision and sum of the momentum of an object after collision will be equal to each other. And Newton's second law will say as F is equal to ma. These are the two formulas what you need to remember when you are going to solve the problems. F is equal to ma and this formula. Clear? Now let us find out how much net force. Force in the sense here they are talking about the second law of Newton. What is the second law of Newton? F is equal to ma. First of all, you write the formula. When you write the formula, you will come to know m into a. Now, force you need to find. F you need to find. Then it is required to accelerate. Acceleration they have given. A is equal to how much? 1000 kg of a car at what is that called? Mass is given as 1000 kg and they have given acceleration. Acceleration is what? 4 meter per second square. 4 meter per second square. Why acceleration is measured as 4 meter per second square? Because velocity is distance by time and you have two things. Velocity is distance by time and acceleration is velocity. Difference in velocity divided by time. Time into time will be time square. So it will be second square. Acceleration is meter per second square. Now let me substitute in the formula. F is equal to what is mass? 1000 into what is the acceleration? 4. So you will get 4000. 4000. The force is represented in which SI unit? The SI unit of force is Newton. F is 4000 Newton. Understood, children? This is the basic problem what you have in your syllabus. That is the second formula. You will be having some more formula, some more sums based on these things only, and you will be using the first chapter's formulas. That is, you will be having the graphical representation of formulas. 3 formulas I had given to. Those formulas are also important when you are going to solve the problems based on acceleration, because all the 3 have acceleration. They'll ask. Based on acceleration, they'll be asking. So you need to remember those 3 also. The next one. If the net force of 7 Newton was constantly applied on 400 grams object at rest, how long will it take to rise its velocity to 80 meter per second? So what they have told here, if a net force of 7 Newton was constantly applied on was constantly applied on 400 grams object at rest, how long will it take to rise its velocity to 80 meter per second? Now, what all is given? See children, what is given? If the net force of 7 Newton. So F is given. What is F? F is 7 Newton. If you see net force only, you just remember the formula, that is Newton's second law. F is equal to M into A. Write it off. You will not forget only. Force was constantly applied on 400 grams. G represents the grams. Grams is mass. They have given mass, which is 400 grams. Object at rest. How long? How long means they are asking you the time. How long? How long will it take to rise its velocity to 80 meter per second? One velocity is given, which is 80 meter per second, and they are asking you to find out the time. Here we have a formula, that is F is equal to M into A. Using this formula, what can I find out? I can find acceleration. So let's substitute. 7 is equal to 400 into A. Now 400, is it multiplied or divided here? It has been multiplied. If I take the multiplied thing this side, what happens? It gets divided. So 7 divided by 400 is equal to A. Yes or no? 7 divided by 400 is equal to A. Now what do you do? Cancel it off. Two zeros are there. If you want these two zeros to go, what will you do here? You are going to add two zeros here. Four ones are 4, 5, 6, 7. 3 is left. So it will be 30. 4 sevens are. 4 sevens are how much? Should I cancel that? No, wait. 7 ones are. I want this to do this. Let me take that one. So 4, 5, 6, 7, 3. So 7s are 28, 28. Again 2 will be left. 5s are 0. I mean, somewhere it is in this here. 400 grams. Here it is in Newton. So you need to convert it into kg. The standard form. So 1 kg is equal to 1000 grams. So 400 grams is equal to dash kg. What you are going to do? You are going to cross multiply. 400 into 1 will be 1000 into x. So you will be having divided by 1000 is equal to x. 4 by 10. So let me take it as 4 by 10 itself. So we will be having what? 10 has been divided. If 10 divides it, if it is going to side, it gets multiplied. 7 into 10 divided by, multiplied 4 coming this side, it gets divided, is equal to A. 2 2s are 2 5s are 2 1s are 2 3s are 6. 1 will be left out, it will be going in 3. Now multiply it, 5 5s are 25. A is equal to 5 5s are 25, 2 carry, 5 3s are 15, 15 plus 2, 17. So you are going to keep, after how many decimal point you have a number? After 1 decimal point you have a number. From the left hand side you are going to keep 1 decimal point. So acceleration A is equal to 17.5 meter per second square. You have acceleration given as 17.5 meter per second square. Now the next thing, what they have asked in this question, they have asked you to find out the time. How will you find out the time? What is the formula is there to find out the time? The basic formula you have is acceleration is equal to final velocity minus initial velocity divided by time. Correct? You have already given the acceleration. Initially anything they have mentioned? No. If the net force is applied, the starting only they have given. At the end they have given to raise its velocity. Rise in the sense initial velocity we do not know, something it will be there. So we are going to take the initial velocity at 0 meter per second. And the final velocity is already raised. Raise this velocity to what? V is equal to 80 meter per second. So let us substitute. What is the A value I have got? 17.5 is equal to V is 80 minus U divided by T. Here T is being divided. If it is going that side, it gets multiplied. So it will be 17.5 into T is equal to 80 minus 0 is 80. Now 17.5, is it multiplied or divided? It has been multiplied. If it is coming this side, what happens? T is equal to 80 divided by 17.5. If you want to remove this point, where are you going to put the 0? Take this point out, put a 0 up. Clear? If one number, if you are shifting, 1 0. If you had one more number, if you had 7 here, if you shift this one, we are going to put one more 0. Clear? How many other numbers you have? That many zeros you are going to put along your numerator. So you will be having T is equal to 800 divided by 175. Both. See here, last one 0 and this is 5. Both goes in 5 table. So 5 3s are 15. 16, 17, 2 will be remaining, so it will be 25, 5, 5s are 25. Here, 5 1s are 5, 6, 7, 8, 3. 5, 6 are 30 and this is 0. Let me continue here. T is equal to 160 divided by 35. Again, in which table it goes? 5 1s are 5, 7s are 35, 5 3s are 15. Here it will be 1, correct? 5 2s are 10. Then again in 7 1s are 32 will go. Will it go or not? 7 1s are 7. 7 how much are? 7 5s are 35. 7 4s are 28. 28. How much you will be left out? 28, 29, 30, 31, 32. 4. 40 will be. 7 7s are 49. 7 6 are 8. So it will be T is equal to 4.6 seconds. Clear? What they have asked you to find? They have asked you to find how long. We have also found out how long it is going to take to rise its velocity. This completes and the remaining chapters will be continued tomorrow.